tutorial. But before we actually begin, be sure to hit that subscribe button and click on that bell notification icon so you don't miss out on any updates from us. So, in the agenda today, we're going to be discussing what is data warehousing, and we're going to discuss what is Hive, which is a data warehousing tool essentially. How does Hive work? The environment in which the tutorial or the hands-on that I'm going to do is going to occur, and then finally we're going to get to the hands-on. So let us quickly understand what is data warehousing. So data warehousing is defined as the process of building and utilizing a data warehouse to derive insights from data that is available to you. So you might wonder, what is a data warehouse then? So a data warehouse is basically built when data is accumulated or collected from multiple heterogeneous sources. So that means that the data will not be coming from one source, will not necessarily be coming from one source. It might be coming from various sources, but what a data warehouse will do, it will give you the combined view of all of that data. So say you're working for an e-commerce organization and you have a user base. So you have some customer data. So that is stored in the customer database. Now for your internal sales records, you have your sales database, right? So from a web application point of view, from an organizational point of view, it makes sense to keep these two databases separate because one might be confidential and the other might be available to a lot of employees present within your organization. So it makes sense in that format, right? But say higher management wants to look at all of this data together, and you basically have the task to analyze the customer data alongside the sales data. So it'll be extremely tedious for you to combine these two databases together and then perform your queries on it. So the de facto solution that organizations use in today's world is extracting this data using an ETL tool. So they extract, transform, and load this data into a data warehouse. So basically the data is cleaned and put into a format that can be used to derive insights, right? And that is stored once the data is prepared, it is stored in the data warehouse. So once it's stored in the data warehouse, the data analysts and business analysts can basically create their insights from it. So it's very easy to create insights and reports from the aggregate data that is present throughout the organization. So now we can understand what Hive is. Hive is a data warehousing tool which is built on top of Apache Hadoop. So Apache Hadoop is a big data technology. So it's one of the first big data technologies in the world that came up with the solution to actually analyze big data. And Apache Hive runs on top of it. So how does Apache Hive work? So Hive provides you with an SQL-like interface, so similar to what you would have in MySQL, and an extracted query language like HiveQL. So HiveQL is identical to SQL. So the similar statements that you would run on an SQL interface, you can run on Hive as well to query your data. So the data stored in databases and file systems that are integrated with Hadoop essentially. So you can have an entire cluster of devices that contain parts of a data set, and all of those combined together basically can be warehoused using Apache Hive. So that is the main advantage of combining Hive with Hadoop. So Hive supports the analysis of large data sets, which can be stored in the HDFS, which is Hadoop's distributed file system. And Hive also has compatibility for other file systems as well, such as Amazon S3 and Alluxio. So say you have your data present within your HDFS. So this data could be structured, semi-structured, or unstructured. You have it present in the form of JSON or CSV or TXT. It's present within your HDFS server. So you'll basically extract that data using ETL and put it into Hive as in data warehouse. And then whenever you run a query on Hive to derive your insights from that data warehouse, the difference that comes in is Hadoop will run MapReduce to actually perform your query to make it faster and basically implement parallelism in it, right? You're not simply doing it on one device. If the data set is spread throughout multiple nodes in your big data cluster, MapReduce will run on each of those nodes and actually analyze your query, create the solution to your query in a much faster time. And then you can finally get your insights and reports once the results of the query are in. So the environment that I'm going to be using for today's Hive tutorial is going to include VMware. So I'm going to be using VMware as a virtualization machine for my CentOS operating system image. So the image is obviously the operating system is CentOS 6. And I'm going to be using Hadoop and Hive on top of it. So firstly, I have my Hadoop installed, and on top of it, I have my Hive installed as well. So without any further ado, let us get into the live hands-on. So we're here at the hands-on section of today's tutorial. So today we're going to be analyzing a taxi cab dataset with Hive. So as we can see, we have a taxi dataset right over here. So we have vendor ID, we have the trip distance for each of the trips the cabs have taken. We have a payment type column, we have fare amount, we have additional revenue related columns, and then we have the trip time, right? So what we're going to do today is we're going to be using this data set to find out some key things about how this taxi organization is running. So as we can see here, the dataset that we just saw is in the format of a CSV file, which means comma separated values. So it's called yellow new.csv, and we're going to be analyzing this. So the first step would include actually transferring this dataset or uploading this dataset onto our HDFS server or our Hadoop distributed file system server. So I'll simply go to applications, open up my terminal, and I'll just zoom this in so you guys can see as well. So the first thing that we will do is actually transfer this file onto our HDFS server. So simply create a folder onto our HDFS. So I'll call this Hive session. So that has created a folder in our HDFS. And now I'll upload this file from my local file system or my Linux file system to my HDFS. So Hadoop fs put, and I'll simply copy yellow new.csv to Hive session. So that's done, and to verify, I'll simply type in Hadoop fs-ls and type in the folder name, which is Hive session, and press enter. So as we can now see, if I expand this a little bit, we can see that we have our yellow new.csv within our Hive session folder in our HDFS. So we'll keep this terminal aside. We wouldn't be needing this. Now the next thing that we would do is actually start up our Hive session. To start your Hive session, simply open up another terminal and make sure you have Hive already installed, right? And I'll just full screen this and zoom in a bit so you guys can see clearly. So simply type in Hive and it will automatically start a new Hive session, and you will be typing in the Hive shell. So right now we're in the Hive shell, and the first thing that we would do is create a database. So similar to how SQL works, you would create a database in Hive as well. So create database YT session. So I'll call this YT session and semicolon and press enter. So we've created a database in our data warehousing application that is called Hive. The next thing that we would do is actually transition into the database by typing use YT session. So we are now using the YT session database, and now we will create our table. So let us create it. Create table, similar to SQL, exact similar syntax. Create table. We'll call this table cab. And now we have to map all of the column names to the table column names. So we'll look at the column names in our CSV file. So first we have vendor ID, and then we have trip distance. So vendor ID is integer, trip distance is a double, and payment type is integer again. So we'll first write these three columns. So integer, double, and integer. So firstly ID, and this is int, and then we have type. So just confirming that. So we have distance, the second one. So let's call it dist, and we will assign the data type of double, and then we have payment type, and this has the data type of int. So let us look at the next columns. Then we have fair amount, we have extra, we have MTA. So fair amount, extra, and MTA, all of those three are double. So fair, double, extra, double, MTA, double. Then we'll look at the next columns. So up until MTA we've written. Now we have tip amount, toll amount, and total amount. So tip amount, toll amount, and total amount, all of them double. Tip, double, toll, double, and total, double. And we look at the last column now. The last column is big int because it has extremely large values as well. So we'll write big int, and this is time. So we'll just simply go to this and type in time and big int. So we've successfully mapped our table to the values corresponding in our data set. So I've copied the entire statement onto a gedit document, since Hive tends to get a little buggy if you keep typing in one line. So up until here, we've successfully written all of the column names. Now what we will do is we will specify the delimiter. So we will specify first that the row format is delimited. Row format delimited. I'll simply scroll to the left over here so you guys can see more clearly. And fields terminated by. So here you can specify what is actually terminating the field. So in our case, it is a CSV file. So commas are terminating our fields. And then we will specify stored as text file. So we want to store this entire table as a text file whenever it's created within the Hive session. And we want to specify the location. So our location, if we just simply remember, it was Hive session. So specify user training Hive session. So you have to specify the absolute URI. So in my case, user training is the absolute URI in my HDFS where the Hive session folder was created a while ago. And then given the location, and then simply write tbl properties, and within this specify that you want to skip the header. So we'll just simply skip the header. Skip header dot line dot count, and equate it to how many lines you want to skip from the top. So in my case, I only want to skip the header because it actually contains string values and I only need the actual values contained in our data set. So I'll simply type in 1 and then simply close that off and change the table name to something that you haven't used before. So in my case, let's just change it to cab, and make sure to put this 1 within literals, so put it within double quotes. Now we're set. We'll copy this and go to our Hive terminal. and simply paste the entire command over here and press enter. So that will create your table from the data present within this location. So now we will look at our table. So select asterisk from cap, similar to what you would do in SQL, and limit it to something that is conceivable in your terminal. So I'm limiting the number of records to 2. So as I can see now, the records are appearing to be 2, and it's in the exact same format as what we can see. So 2, 1, 1, 5, 5, and 2. And we can see that over here. So we've successfully warehoused the data set, and now we can perform queries on it. So this is how you would perform queries on big data as well. So extremely large data sets in extremely low amounts of time with the help of Hive. Now let us get into questions and use cases that may come up if you're working for the industry and analyzing data. So for a beginner level question, say your employer wants to find out how many trips were taken in total with regards to the data set. So how would you go about that? So it's quite simple actually. You will simply write select, and you will use an SQL function because HiveQL is an SQL-like language, as we had discussed before. So simply type in count and put in an asterisk over there, and type in from cap, right? So when you do that and you put a semicolon over there and you press enter, it will basically show you the number of records in this particular data set, which is equivalent to the number of trips that have been taken. So as you can see, MapReduce is working right now. So since we are currently operating on a small data set, we wouldn't notice the difference in time. But just imagine if this were an extremely large data set, right? And you were operating on this extremely large data set on an extremely large Hadoop cluster. So in that case, what would have happened is it would have taken the exact same time to give you this result, regardless of the size of the data set. So right now it's 10,000, but even if it was like about 10 billion or 10 trillion, it would have still given you that answer in the same amount of time. Let us take another example. Say if you want to find out, or if your employers want to find out the total revenue that has been generated with regards to the data set, the total amount of money that has flown. So the column that we need to refer to basically is this column, which is the total amount column, right? And we've specifically named this column, as we can see, the total is this, so it's called total. So what we will do now is simply type in select and use the SQL function sum, and within that type in total. Once you've done that, simply type in from and given the table name, which is cap, and press enter. So this will start another MapReduce job, and it will calculate the sum. It basically calculate all of the column values of the column total that we've created out of the data set. So it took some time, but we can see we have our double value. So it's about $160,000 or rupees, whatever the currency amount is. So we've gotten that answer. Now, say if you want to find out of the total revenue that has been generated, what is the fraction of tolls? So how much toll have you paid? So basically, we're going to divide the total toll with the total revenue that we are generating. So let us go about that. Type in select sum, and on the numerator side, we will type in toll. If we simply scroll back up, we can see that we've written that column as toll. So we're going to refer it as toll and divide it with a division operator with the sum of total. So sum of total, as we had seen before, was the total revenue that had been generated, and from the table cap, put a semicolon over there and press enter. It will start another MapReduce job, but it'll but it will give us the exact fraction or the decimal value at the end of that job. So as we can see, it's about 1.5% or 0.015 of a fractional amount. So this is how much out of the total revenue accounts for the toll that is given by the cab drivers to the road authorities or road maintenance, basically. So if we scroll back up and look at the columns that are present, right, if we just scroll back up and look at it over here, so there's also a tip column. So if you want to calculate the average tip, right, so what would we do? Simply scroll back down and type in select EVG, which is another SQL function. So if you're familiar with MySQL, you would know about this. Type in tip within the brackets from cab and press enter. It will start another map reduce job, and at the end of it you will get your average tip. So we can see the average tip is about 1.7. So that is there. And similarly, we can perform other operations as well. Suppose we want to calculate something and group our answer by the payment type. So if we simply open up the data set again, we can see that on the third column we have payment type. So this could be online, offline, through card, or some through wallet or something, right? So that is why we have these numeric codes associated to any of those. We don't really need to know what codes are associated to what right now. We just need to know that there are separate codes right now. So what if we want to arrange our output and order it or group it by these payment types, right? So if I simply minimize this and go over here and type in select average fare and payment type or type, because we've inputted it as type. If I simply scroll back up, I'll see over here that it's type. And then from cab, and we want to group this by type and simply press in a semicolon after that. So that will start another map reduce job, but at the end of it, we will see for each payment type the average fare that has been generated by the cab drivers. So we can see that for the first payment type, whatever the type is, the average fare is about 13. For the second payment type, it's 11. For third, it's 13 again. And for four, it's about 12. So there are 4 payment types, and we've grouped our output according to it. So all of this basically goes out to show the strength and convenience of big data technologies like Hive. So you're implementing basic SQL, except even if you have an extremely large data set over a distributed system, over a distributed file system, it's very easy for you to query that data with the help of Hive or any big data technology for that matter. So that is what we're essentially doing here. So no matter what background you're coming from, whether you're coming from a Python background or a Java background or an SQL background, everybody can basically get into big data and get their career started in that particular field. So that is about it for our session here today, guys. Make sure you sign up for our webinar in order to ask us live doubts regarding these subjects, or chat with our course advisors for that matter. And that is about it from Intellipaat. The link for the webinar registration is in the description of this video, and we hope to see you again next time.